So in this particular topic, we will be discussing that light is actually also a wave, and this was proved by the interference of light waves by Young's experiment. Young's famous double slit experiment. It proved that light has also a characteristic of a wave. Light possesses characteristics of a wave. So now let's see the setup of Young's double slit experiment. So what he did was he took a source, since this is a source, so all the waves that it is emitting will always be in phase because this is coming from the same source. So what he did was, to get a coherent source, he used a single source, and he put a and he took two very fine slits, so that light passes through these two slits, and this in turn is the source. This two in turns becomes the source of light. So this source is S1 and this source is S2. Now this is your screen. This is your screen. Now we consider a point P in the screen. So now if you look at the distance between these two, so this is S1P and this is S2P. The distance between these two is D. Distance between these two is D. And the midpoint, say from the midpoint, let's join this line. Let's join this line. So let this be O. So the distance between this line, if we talk about the distance between this line and this line, is actually D. That is capital D. And say suppose this distance from the midpoint to over here, let's say this be X. So this was the whole arrangement for our Young's double slit experiment. Now after the experiment, let's first talk about the findings. Now what he saw was, the light being, that is the source is the same. We observed that at different points it creates ring. This is a ring, and that ring slowly is very dark or very prominent in one places, and slowly and steadily it vanishes, and then again after a certain distance the ring again comes into play. So we can understand that the point where it has interfered constructively is a point of high intensity, that is dark fringe, that is bright fringe, and where there is no fringe, that is we are calling this as fringe. And sometimes when the waves interact among themselves destructively, that is they cancel each other, because the displacement is opposite in magnitude, and that is the magnitude is same but the displacement is opposite in direction, then they cancel each other. So that becomes the position of no fringes. So there is this light and dark that has been formed, and this particular finding proves that light itself is also a wave, because it is affecting, or because it is acting constructively as well as destructively. So now this is your whole setup. So if you look at S1P, if you look at this S1P, this is S1P, and this particular length is your S2P. So now if I want to do the calculation, let's see, S2P whole square minus S1P whole square. This is given by, what is S2P? S2P is nothing but your this is a hypotenuse. If we consider this to be hypotenuse, so this is the base and this is a perpendicular. So by Pythagoras theorem, d square, if you look over here, this is d square. Now, what about this length? What about this whole length? You know, this is the midpoint. So from the midpoint, if you take, this is x, and what is this distance? If as a whole this distance is d, so this distance is midpoint, so this distance will be d by 2. So x plus d by 2 is your required distance, that is p and say z. Your pz is nothing but your x square, sorry, this is x plus d by 2 whole square. So this is given by x plus d by 2 whole square. So this particular length is given by d square, a square plus b square. So what is b square? B square over here is x plus d by 2 whole square minus what is S1p. If I'm talking about S1p, I'm talking about this length. So S1p is nothing but your, this is d square, this is minus d square plus, now what is this length? This whole length is x and this length is d by 2. This length is d by 2. So this particular length will be given by x minus d by 2 plus x minus d by 2 whole square. So this is what we have. If I open the bracket, this d square and d square gets cancelled out. So this is x square plus d square by 2 plus 2x d by 2 minus x square plus d square by 2. This was minus, this was whole minus, so this was 2 into x into d by 2. So this x square, this x gets cancelled because this is a minus sign. A minus is in front of this. D square by 2 gets cancelled and minus minus becomes plus. So this becomes xd plus xd because this two also gets cancelled. So this becomes twice xd. So the distance is twice xd. Now we had a condition for a constructive interference and for a destructive interference. So when will this be a constructive interference? Twice xd, that is the distance between these two, will be twice of x into d. S1p square minus this particular distance minus this particular distance. Now if you look closely over here, what is this? S2p plus S1p into S2p minus S1p. So this is actually equal to 2xd. So let's do this calculation in the next part. So this is the derivation, or this is the final result that we had. Now why is this? Because we proved that S2p square minus S1p square is equal to twice xd. So breaking this into a square minus b square, which is equal to a plus b into a minus b. So this is our breakdown. Now if you look over here closely, what is S2p minus S1p? This is actually equal to twice xd into S2p plus S1p. Now there is an interesting thing that we know. The distance between these two slits is very less than compared to the distance between the source and the screen. So now if you look at this S2p plus S1p, what is this? This is the length, and if we consider this to be very small, if we consider x and d, if we consider x and d to be very small as compared to this distance d, then we can write S2p and S1p to be d plus d. So S2p minus S1p in a way can be written as twice xd into twice d, which is nothing but xd upon d. This is nothing but xd upon d. So now, if the difference in the path is in a multiple of say n lambda, we had already discussed if the difference in the path is a multiple of n lambda, then we will have constructive interference. So this particular equation becomes, let me use a different color, becomes xd upon d. So at what position of x from the center now the, if this is S1 and this is S2, see suppose this is the center and this is the source. So from the center at what point should we will get the bright fringe and the dark fringe will depend upon this, will depend upon x, this distance x, and this x is given by, we know the bright and dark fringes is given by n lambda. That is, for constructive interference we will have a bright fringe, and this is the generalized condition. This is the generalized condition. So if we follow this condition by putting n equals to 1, 2, 3, 4, 5, 6 and so on, we will be getting bright fringes. So what will be the value of x for this? Therefore x is actually equal to n d lambda upon d. N d lambda upon d. So this is the condition. So the first bright fringe will be formed at x equals to 0, at this point, at x equals to 0, putting n equals to 0. The second, or you can say after the midpoint, the first bright fringe will be formed at n equals to 1. Therefore x equals to d lambda upon d. At this point, the second bright fringe will be formed. Now, what about the fringe width? If you want to know about the fringe width, all you need to know is what is the fringe width. Fringe width is take n equal to 1 and n equal to 2 and subtract the distance between them. If you subtract the distance between them, then what we have is fringe width. B is known as fringe width. Let me define B. This is fringe width. Fringe width. So what is the width of the fringe? What is the width of the fringe that we want? So this width is given by, take n equal to 2 and take n equal to 1 and subtract this 2, you will get the distance. So fringe width is given by d lambda upon d. So this is exactly this, d lambda upon d.